the first part isn't about their results. It's actually just it's about their, what do you call it, demographic info. And so they've run statistical analysis on their demographic info to show. Let me just scroll across.
Yeah, you might have to zoom in a bit, I think.
Yeah, are you guys, is it blocked? Okay, so, oh wait, I can do this. Okay. So the first ones you can see there is there's age, there's duration, like there's some baseline characteristics they call it, and then I just scroll across. It's blocked from, there we go. So you can see the p-values there, right?
Yep.
So then those ones there are non-significant, like the first couple, because you don't want significant differences in age if you're trying to, like, does that make sense? Like, age isn't what they're trying to test, so they don't want significant differences.
Okay. Is that like our descriptive statistics?
So that would probably
really,
be more about your responses.
Yeah, okay.
So you guys have, let me just get it up because I know I've got it. So did you end up breaking, so it's income and physical activity, right?
Yes. Income categories, low, middle, high.
Low, middle, high. And then activity. So some things you could look at, like for instance, gender, age, like, so these are the things you don't want to be different, right? Because you wouldn't want a group with all females in the low income group, because then what if they just tended to exercise less or more than the males?
Well, our data set already broke all of that up in the first place.
Yeah.
So we already split the 100 participants into geographies, equal genders, equal geographic locations, and equal ages between 5 and 17.
Yeah. So do you have, is everything equal then?
Yes.
More or less. It's very close. There's only maybe one extra person in each age.
Okay. Well, maybe you can just talk about that instead. But one option, which is what a lot of the groups have done, is like you can actually run a test and see, instead of your response variable being the amount of physical activity, it can actually be age.
So that's just seeing if something else was.
Yeah, and so you should get essentially like a 0.8 p-value or something like that. So you can actually run some tests on if there's any, I mean, if they're perfectly equal, like if you've got 2 5-year-olds in every group, 2 6-year-olds, you know, just like as an example, then there's probably not any point in running that. But if there's just like, you know, really low differences, like say there's 50% males in your low income group, but 55% males in your middle, you can run a t-test on like ratios and things and and obviously the p-value is not going to be significant.
Yeah. I know one of the questions I had from our data is so when we took all the kids and then tried to compare them to try to split them into groups and look at exercise, there was absolutely no correlation with income and physical activity duration, and no correlation between income and whether or not they hit the WHO guideline, which was the latter was probably our main question.
Yeah.
So then what I noticed is when we looked at the chart of, you know, kids who exercise, it was like once you remove all the zeros, there was like an approximate normal distribution in terms of physical activity duration.
Maybe, Jasmine, just look at pages 13 and 16 in what I just sent you, and then that'll make sense what Jason's trying to tell you. Just in the chat document, just double-click on the chat document called Observations.
The Word document?
Yeah, the Observations of
okay.
Tests. And just look at page 13. That way it's easier for you to understand what Jason's saying.
Okay. Where did that go? Here it is. Yeah, so you're saying that
it was like amongst kids who exercise, there was an approximate normal distribution in exercise duration.
Yeah.
So then we did, I think, so Danielle ran some more tests on that, and I actually got a little bit confused. So it looked like the Watson-Kruskal wasn't, sorry, Actually, sorry, Jasmine, would you mind sharing your screen so I can make sure we just look at the same thing? Because it's going to help me see it.
I'll share like the document.
Yeah, that'd be great.
Yep.
Thank you.
Yep. Just go. Yep, this is the right one. Cool.
Yeah, beautiful. So, if you scroll down, please. Probably a little bit further down. It's like page 13.
Oh yeah, right.
There's just a lot of stuff in there. So here, this was one that popped out where it was like, so once we removed the kids who don't exercise, there was a trend to reduce activity duration with income. But I can't remember. So Danielle, did that work out to be statistically significant or not? I got really confused. So it looked like you said it did, then it didn't.
So no, it's not statistically significant according to the stats, but there is a mean trend, right, where when you reduce physical activity, household income increases, the mean.
Yeah.
I was just thinking, because that's a Wallace Cross score, was what you use for non-parametric data.
Yeah.
Did you get the ANOVAs out? Is that at the bottom of that document, Danielle?
It's at the bottom.
Do you mind scrolling to the bottom, Jasmine? Because I think there's an ANOVA down there.
We don't want that.
I did an ANOVA with the main data set with gender and islands, and I got significant values of 0.276 and 0.4, respectively.
So that's just saying no association with gender and age.
0.2 and 0.4?
0.4 and 0.278 for gender and, well, one's geographic location.
Was this like gender across the three groups? Is that
Yes.
what that is?
Yeah, just between groups, within groups, that ANOVA test. So the exercise minutes per day and gender. So the significance was 0.278.
Yeah.
And then I did geographic locations because you never know. 0.404 was that one. And I never did age. But
Yeah, so that's like...
Sorry, yeah.
Yeah, that's like the demographic stuff that you can include those p-values to sort of like make your results, like explain the validity of your results. Because if you get non-significant p-values, that's telling us that your groups are the same. So there's no risk of bias or anything like that. So you can report those, which is what those papers had done, which is what I shared. That's like a, medical paper that it was doing some sort of health study. And they've just included this whole table of, possible factors and non-significant p-values. Okay,
so the fact that we got 0.278 and 0.404 is something to talk about in itself.
You could, it's just like briefly mention.
Yeah. I realise don't go into it. Just that it's less than 0.5.
Good, yeah. So
look at this. So between group, there was no significant difference. So just double checking, just confirming that even when we remove the kids who don't exercise, there's still no association. It's just like there's a trend,
definitely not.
But it's not significant, so it could just be
So when you can, the whole reason we do a p-value test, we test to get a p-value, is so we can say there is a difference, because remember, we've just taken a sample. So there very well can be differences, like the means could be like this, but if it's not statistically significant,
it could just be chance.
So then we basically, if we can't reject our null hypothesis, we basically are saying that they're equal.
Awesome.
That's kind of how, so it's probably not worth removing data for it, just because as well, you've got no real reason to remove the data.
Yeah. So
it's kind of a weird, if it was a different factor, but if you just take out half the people and try and get a significant result and it still doesn't work, if it was really significant, it could be worth talking about.
Yeah, because what I
initially
thought was it'd be we'd report on the total group, say no association, and then when I saw that trend, all right, if we remove the kids who didn't exercise out as association, because there's still no association, should we only really just report on the main, the everyone group?
Yeah, I think Jasmine is saying just report on the legitimate data set. Is that what you're saying?
Yes, so don't need to talk about this.
Yeah. Okay. Also, is your main sort of analysis was it the non-parametric one because it's your data's not normal?
Yeah, the Wallace Kroskal and the chi-squared are what I think we should use most. So the Wallace Kroskal is like
Yes.
your
Okay.
ratio in group, and then the chi-square is the main question, which was do they hit the threshold in group, and both.
Yeah, there's like you basically do expectation over like expectation and observed proportions. Yeah.
Yes. And,
yeah, if you meet the chi-squared would be fine as long as you meet. There's just those few assumptions for a chi-squared. Basically, like, yeah, I think it's something like each group has to be greater. I can never remember it off the top of my head, but there's just a certain size for each category, like sample size that you have to meet.
I should have like that, so I'll
I
definitely
think
look
it's just
at that.
two. I think there's just two assumptions, and as long as those two were met for the chi-squared, we could definitely use that.
What page is our chi-squared on, Jason?
Yeah,
I'm trying to find it.
I saw it.
It's Pearson. Starts with Pearson chi-squared. Should be at the top-ish.
This maybe.
So the assumptions were that we're dealing with frequencies, which
here
we
we
are, and variables are mutually exclusive, which we are. So we hit those.
Cool. There is another sort of assumption part, which is like sizes of the test.
Oh, okay. Yep.
See it?
At least 5.
At least 5.
Yeah,
Which
we got at least 20. For the
yeah.
score.
I think there was. Is there one more value there that's you need to meet?
Let me have a look.
I don't know.
That was just a Google check. Let me try through Edge.
Yeah, because I mean I could have had a look too, but I think there's 2 things that they've mentioned in the edX to like just check. I think you meet them fine because you've got plenty.
Yeah.
Well, we'll still have to refer to it, Jason, as far as our
Yeah, for our little like
Yeah.
convincing people that we understand the theory.
Yeah, and so this would be good because, and then just remember that they want a section where you justify why you chose this test over the others, which can be as simple as you chose the chi-squared because you have counts rather than quantitative data like a regression is and things like that. You just need to justify based on like what sort of test it is.
Awesome.
But we can double check that next week. But yeah, make sure the assumptions are met.
Oh, we do get it next week. How good.
Yeah, we do. So
Well,
that's
it's-
the final questions.
Yeah, but I mean, it's pretty much all over by then, isn't it?
Yeah, but like the main things, like I said, there's still no problem with like not having a difference. You can
That's
still
awesome.
justify quite well, and just look at the example paper that they give you in the assessment tab is actually not significant as well for their phase 2.
Yeah.
I've been thinking, like, in terms of talking about exercise and income, saying there's no relationship is still useful because, like, when it comes to implications, we're talking about like public health.
Yeah, exactly. And then the fact that there could be other things that you didn't check that could be future research and things. Yeah.
So, Jasmine, is there any tests that we shouldn't have done for very good reason, based on our type of study and our measures?
ANOVAs, we don't need them.
Yeah, and just the fact that it doesn't meet the normality assumption, so you probably couldn't do that anyways. But then the chi-squared, I'm like 90% certain you don't actually need that because it counts. So yeah, that's just So like there obviously is a couple of studies analysis that you definitely shouldn't do, but that's why you chose to do the chi-squared. You don't need to have like 3 different analyses.
Okay. Yeah. It's just that they had allocated 100 words, which they hadn't done in the past, just to going through, I guess, the edX quantitative theory.
Which is essentially going to be like you basically justify the chi-squared for your data over, a couple of the others and say why it suits it the best. Just to show that you understand what each of them is for, like each main analysis. So like ANOVA, the regression that we did today, like they obviously don't match your data set, but you just explain specifically why.
Okay. Does that make sense, Jason?
Yep.
Yeah, cool.
We'll go on that.
Awesome.
Yeah. You've been so helpful, Jasmine. Thank you.
Thank you so
I'm
much.
glad. It's looking really good. So we can finalize the last finishing touches next week.